get to do streaming. So we can talk about chapter 4 to review the concept of the functions of the math class. So pretty much we talk about object for the Java API, right? That we have the class math. To access to the method of math class, these are static methods, so we just call the class name dot, right? And technically it can return the, like if you want to find sine, we provide the radians, return the value of the sine, cosine, arc sine, arc cosine, arc tan, and tangent. You can convert degrees to radians to degrees. Pretty much just like your scientific calculators, right? But using Java math class. We also have exponent to provide the value of the e to the right number of the power raised by the power. We can find log base 2 or log base 10. This is log base e, which is ln, and this is just find the power. A is the base and b is the power. Find square root. So we also use math dot right away. These are statics methods, like we talked about that already, so that's the reason why we talk about this later. It's easier now to understand. Ceiling, floor, round, integers, round up, right? Round. So round up to its nearest integers, right? When you do round int, and when you do round, it returns just like math.floor, but it returns the integers of that. Right, the difference than ceiling and floor, because ceiling and floor returns the double values. So round, now it's going to return like math.floor if x is the floor, and returns math.floor if x is the double, like in long type. If it's floor, it's going to return an int type. If it's double, it's long type. Like that. When you provide float, you have to do f to the value, so it's going to return integer type. When you provide int, it's going to return long type. And then we have also find min and max of the two numbers. We can find the absolute values. We can get the random numbers that returns between 0 and 9. We were talking about this, right? And you see this on the test. Okay, multiplied by 10 and int. So in this case, what is the value that we should have? Pretty much number between 0 and 9. All right. So if we do, how about this one? Times 50. So math.random returns between 0 and 1 times 50 is going to get what? Starting from it's pretty much just going to be 0 up to, so since it's 0 and 1, it could be 0.9, right? 9 times 50 is going to be 40. This is going to be, it's about 45, right? 95. So it's going to be, but it could be 99.9999. So that's why it can be up to 49. So that's why when you add 50, it's going to be between 50 to 99. Like this, you can see, like I said, this is an example on for the test, right? So like this one, So method random times b. So tail is going to return number between a and a plus b. Right, so that's pretty much just the format for that, as excluding a plus b itself. Just like that example, it's between 50 and 99 excluding 100, right? So this is just showing how to compute an angle, like this is geometric, but using math dot, right? Square root, math dot, arc cosine, because this is a formula for that, arc cosine. So pretty much just very simple, just plug in the numbers. So just try to show you how to use math class. Now let's talk about the characters data type, right? Pretty much we call it a char, right? Char, like letter char, letter A. Now when I give the number of the num char, right, the second statement assign digit character 4 to the char. So character 4 to the char, that's how you assign the digits. So let's try a little bit. Now let's see if I start to say char num char equals to 4, right? And if I say char a char equals to 4, so what's the difference between num char and a char? So if I print out, what do I get? Remember on the test you don't have a computer in front of you that you can type. In that case, you pretty much have to know it, right? So this is will return an ASCII code number 4, but that's gonna be characters number 4, right? Like for example, 96 is, I think 95 is A, right? Caps A, or let's check the ASCII table. We talk about 96, that's why I get the quote. 97 is lowercase a, right? 65 is cap A. So that's why I print the quote, right? Oh, it's 96. So if I do 97, it's going to be lowercase a. So it's pretty much just return the ASCII code when you assign a number to a char, right? Lowercase a, right there. Alright, so those are the some of the things that we should know. So this part talk about Unicode and ASCII code. ASCII code is pretty much just 1 byte, but it's not enough to represent the foreign characters. So technically, like for example, I said 97 is a ASCII code. With that, I could do the Unicode, which is Unicode just do /u 0097. It's pretty much just appending 1 more byte, make it like each digit is 4 bits, right? So 1 more byte, right? Make it like more data to represent. Like in this case, let me check the ASCII table for binary or hexa. Yeah, it's 61. So since this is going to be a hexadecimal or binary numbers, so we call hexadecimal to represent that. So see that is 61 is A. It's no longer use decimal, right? So meaning that if I want to print out a Unicode, so in Vietnamese you use you have the keyboard for that, right?
Mm-hmm.
For the alphabets, right?
Do the same keyboard.
Yeah, but you have the letters for it, right? The fonts. No? You use English alphabets? So you don't have any special characters? I thought you have something.
We have accents.
Yeah.
We just use the same keystroke.
So let's look at the Unicode. Here, Vietnamese font. Oh, you use the keys, huh? But let me see, there's Unicode. So let's look at Unicode first. The chart. So let's try to show you, pretty much just try to represent all the world font, right, with the standards. So that's why the characters here pretty much just depending on the code for the Unicode, right? So we take a while here. Alright, like those are the CJK, it's the Chinese alphabet. Like if I want to print that 3407, so I just put Unicode 3407, that type of fonts. CJK stands for you see that the fonts show up now in the Chinese alphabet, right? CJK, it's Chinese, Japanese, and Korean, yes, section. Because they pretty much they kind of inherit the fonts from each other, right? Like Japanese, Korean, pretty much just, I'm not sure, but I thought it's from China originally. So that's why they have their own fonts later on. Okay. So let's group them into the same set here. Alright. That's about the characters, and we talk about the Unicode and ASCII code. So ASCII code pretty much just the English alphabet. So let's look at if I want to do the casting. Like if you look at this is a hexadecimal number, and hexadecimal number we know that each digit represents 4 bits. So this is going to cast to char by picking the lowest hexadecimal number, which is 41. Then char pretty much is going to do like 0041 because you can do 2 bytes, right? Because it's Unicode, right? So that's why it's giving you a letter A, because 0041 is a letter A. But you cannot pick the higher 4 bits or 2 more bits A, you know, 2 more nibbles they call, like another byte. Okay. Now if I want to cast the floating point 65 to char, so it's going to pretty much just take the decimal, the whole number part, which is 65, which is in decimal 65 is a letter A. So let's give it the letter A again. Now if you want to cast a characters to an integers, it's going to give you the ASCII code of the caps A, which is 65 in decimal. Now the implicit casting, explicit mean you have to write out a casting inside the parentheses when you change the type. The implicit mean you don't have to write out, like this one. Like this is a char type, this is the byte type. So this is called implicit, right? It can be used too. And the result is going to be, it's going to cast into the byte, which is, it's going to print the byte of a letter A out. Like this one is also print the decimal of the letter A out. So let's see, for example, if I do, these are the characters, right? 2, 3, right? And this is implicit, right? Casting. So we have to see what is the 2. So if you look at in ASCII table, I'm looking for number 2. Okay, I think let's test that. Alright. So we were talking about a couple things first. Let's test the implicit casting byte B and int I. Okay. So byte B equals to A. Int I equals to A. Right, this is called the implicit casting. So now we're gonna print out the values of B and I. Okay. So it's going to change it to 97, right? An integer decimal 97, and also this is the byte. We know byte is pretty much started number, right? Right? Byte 8 bits, int 16, right? So that's why it's also 97. Now let's look at this one. This is a Unicode, right? Can we fit into a byte? A byte is only F4, right? Like in this case, it cannot fit, right? It's going to be incorrect. You have to cast it, explicitly casting. Like you can't just type like that because the size is wrong. It's going to be wrong. So it's going to be an error, right? Variable B is already defined in the scope. So you have to do explicit casting. So let's see if we do explicit casting. Oh, it's just the same name. So now if I do that, there's going to be errors, right? Incompatible types, char and byte. So that's why we have to do explicit. In this case, after you do that, it's going to take what F4, and whatever F4 value is going to pretty much just print the numbers. So F4 is what? 1111. So if you convert F4 to a binary, you're gonna get F4 is 1111 and 4 is what? 0101. No, 0100, right? So that's gonna be, if you convert this back into decimal, it's gonna be and this decimal of this version is going to be what's the decimal? Plus 4, 8 plus 4. So that's why we get negative 12. Are you with me so far? If you know how to convert the binary to decimal, so first, yeah, you don't need to worry about that much. These guys do it for you, but I'm going to tell you how we do it. This is the concept of the negative numbers. Whenever the most significant bit is 1, this is a negative. That's why I put a negative first. Remember, like I told you, right? If you have 8 bits, you can only represent 2 to the 7, 2 to the 7 minus 1. Because half of them has to be negative, right? So those ones are the negative one, right? That's why we minus 1 of the first, the 2 to 7. We only look at 2 to 7 bits, right? So now we only concern about, we want to convert this to decimal. Since these are the opposite set, remember they have positive and have negative. So that's why you have to do opposite, like 1 back to 0. Because it's going to be the opposite set, like this is the positive 12. So 1 back to 0, 1 back to 0, 1 back to 0. 0 back to 1. And 1 has to be back to 0, right? And 0 have to back to 1, and 0 have to back to 1. And I have to add 1 because the positive happen to have the 0. I have to add 1 back. When I add 1 back, that's why I'm actually getting 0000 and then 1100. It's just 1 plus 1 carry 1, 1 plus 1 carry 1, and 0 plus 1. And then I convert this set to pretty much 2 to 0, 2 to 1, 2 to 2, which is 4. This is 2 to the power of 2 is 4, and this 2 to the power of 3 is 8. So 8 plus 4 is 12, so it's negative 12. You learn this more in 205 in details. Okay, so that's why I don't have to worry about that much. But just know that this is how we convert it. This is called 2's complement. The technique that how machine understand the negative numbers. Okay? Or you can review that. Like just look at, just if you still wonder how, just look at 2's complement. Okay, technique. Or just use calculator. It's gonna give it for you, right? So if I put minus 12, you see, I get that back. And it's actually matching to this F4, right? F is 1111, 4 is 0100. Okay? That's pretty much the technique to convert hexadecimal to binary. Alright? Now, we understand when we cast, it's going to convert your F4 into the integers. value again, which is give you this from here, give you minus 12. All right, so now I think you can technically write an app for that, you know, right? In my 205 class, students just write an app for extra credit, like convergence. Right, let's go back. All right, so now let's look at what is the value of I when I do 2 plus 3. And 2, this is the 2 in terms of what? Characters, right? So if you look at 2 is 50, 3 is 51, right? Because characters is going to change into decimal, right? So that's why the answer is going to be 101. Make sense? So when you're dealing with char, you pretty much have to understand this concept. Now 2 plus A is 97, 97 plus 2 is 99. Now if I do char for J, I cast char, J is 99, then 99 is going to give you C, right? Because 97 is A, 98 is B, and you cast back to char, you get C printed out. This is just concatenating, so nothing different. Chapter 2. Comparing and testing the characters. So, two characters can be compared using the relational operators, just like comparing two numbers. So you see this is going to be smaller than B, which is true, because pretty much it's ASCII code, right, that they use to compare. Like this should be false because uppercase is smaller than, right? So this is 65 and this is 96, right? 8, the same, is going to be greater. Pretty much just 97, right? A, okay. This is a numbers ASCII for that in decimal. So you could compare them. Now look at this same is true for the uppercase letters for the numeric code. So this probably can be used to write the code to test characters. For example, the following code tests whether a character CH is an uppercase letter, a lowercase letter, or a digit characters. Alright, so because you know that, like, if you have an input, you just put into CH, and you want to see if it's greater than or equals to A and less than or equal to C, then it's an uppercase letter if it's between this range. But if it's between this range, then it's a lowercase letter. But if it's between 0 and 9, then it's a numeric characters. So that's pretty much use that to help. And we also have the characters class, which has a method for you to call. Is this a digit? Is this a letter? Is it a letter of digit? Because char itself, we don't know. It could be a letter when it falls into this range. It could be a digit when it falls into this range, right? So that's why we call the method to check. That's another way instead of writing your own like that, right? This is if you have the char itself, but this is if you make a character class and call the method and pass the char to test. Is lowercase, is uppercase, pretty much just checking in the range right there in the algorithms into the method. Okay. You could convert to lowercase, convert to uppercase, which pretty much just return that letter A or subtract, right? Or a letter A add with a constant number to that ASCII. Alright, so that's pretty much the character class. These are just checkpoints that you should review to prepare for your test. Now we have string type. So if we already know string class, this should be easy. We know that there's a method length to return the size, right, of the characters. Char add to return the letter at each index. Concat just appending the string to another string. Uppercase, lowercase. So what's trim?
It just removes the spaces, right?
Right, it's going to trim all the white spaces. Like, the reason we want to do that because, for example, when you sign up for account, you may happen to create username and you happen to hit space but you don't see it. Then the application should trim the white space, the extra spaces, right? Before you store information. Otherwise, users try to log in and then it's not going to work because missing that white space. Same when you do login, you just do trim before you, right, authenticate. So this pretty much something that we already know, right? The methods. It's just review again to show you that how you think the term of object, right? Think in terms of objects, and then when you think in terms of object, it's make it like Java API, pretty much an object-oriented programming. Because a black box like string, then you use the method to access, right? Dot, 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 right? Like dot next to get input scanner, right? And string itself has a method like char add. Like string, you can do dot char add, put an index, it returns the letter at specified index out, which is index 0, first letter. Yes.
Can you scroll up a bit? I saw that the welcome to lowercase was changed to a small lowercase. You said that strings are immutable.
To lowercase?
Yeah.
Right, so all of them change to lowercase. The uppercase W comes to lowercase, right?
But you said that strings are immutable.
Remember, it returns. It said returns a new string. It's not changing the original. It's creating another object. Just like I show you here, right? See, it's no longer have that question. But this one, I returned a new one and print a new one out. But the original one never changed, right? So that's an example of trim. Like when you have tab, space in front, and space at it after T and new line, they trim them all, but not in between, right? We still need it. It's just trim the beginning and the end. And we have another set, right, for comparing strings, like equals compared to string. If it's the same, then it's true, otherwise false. Compare to, return 0 when it's equals, negative when it's less than, positive when it's greater than. And you can do equal ignore case, compare to ignore case. You can look at start with, returns to if the string start with the specified prefix or ends with, and contains the substring. right? So this is just showing how to use that. So you cannot compare string by using the relational operators like greater than, less than, equals, and you don't want to compare like equals for a string with 2 equals to. You want to use the method. You want to keep this for the char or the primitive data type. String is not a primitive data type, it's an object. When you deal with object, you always use the methods, even the comparison. So this is just, you can get a set of substring out. So you pretty much could go back and test all this method on your own. Okay, it's just the way how you use the method. Now this one is about how you convert string into numbers. We talked about the wrapper class already, like integer, parse in, you pass a string, you get an integer value of that string, as well as double. Okay, so we just use the parsers from the wrapper class. All right. Oh, this is a good game. You just make an application. It's just, you could find out the date of the month when your friend was born by asking 5 questions. So we have 5 set of numbers. You can try, like, ask if the days is in the set, like your birthday is in one of these set. The date, okay. If you say, like, we keep recording, like for example, this guy birthday is on the 19th, so we see 19 is on this set, right? And this 19 is on this set, but not this, but this. Then you just take the first number on each set and add them all together. You get the date of your friend's birthday. Okay, it's just a guessing birthday application that you can write. So technically in application we just create the string of 5 sets, initialize day to 0, prompt the user to write response if one of the number of his or her birthday in the first set, enter 0 for no, enter 1 for yes. If the answer is yes, then you accumulating the day of the first number, which is 1, right? Do the same for set 2, right? And third set, and fourth set, and fifth. The fifth set is 16, and then just print out the accumulating day. It's pretty much just a simple application and make a game fun a little bit. And another one is this one. Pretty much, if you're taking 205 with me, you get to write this application, converting a hexadecimal to decimal. And you technically need this. It's very simple. We learned that char can do a lot, right? And we also learned the integer, the REPL class can do parsers to the radix, right? So, I mean, if you plan to write an app that people will download, this is the app that people will download. And it's easy app to create, right? Like number conversions here. All right, so I think that's pretty much almost everything. Let's look at the format a little bit. So printf is to print the format, right? Like when you do system.out.print, it doesn't do the format. Like we have %b stand for Boolean, C stand for the characters, D stand for decimal, like the whole number, decimal integer, okay. %f stand for the floating point number, %e for the signification exponents, and %s for string. Now, if you want to print a format, we can do printf and put a string that you want, but you use this percentage as a placeholder for the format that you want to print out. So this is like a placeholder. Like if you want to say count is, then you put the variables here and the value itself go into first one is the %d, which is 5, and the second one go to %f. Like if you notice that that's more into this, like you could control the length, the width of the printout. You can append more white spaces in front. If you put like 5 in front of D, it's going to append 4 more spaces, and including the digit itself is 5. So like percentage at 5C is going to add 5 more spaces. 6B, pretty much if you see, like for example, let me show you. So if I want to print F, so print with the format. So the common one that we normally use is, let's say I have a double value of pi equals to 22 divided by 7. You know pi is keep going, right? Now I want to print this out. How do I print it out? If you do dot print, technically what it's going to do, it's going to keep going. But I say I want just the first 2 decimal places. How do I do that? I do printf. So I can say just %, and this is a f, right? And then I can say pi, and this one has to be inside a quote, and I could do 1.2. 1 represent the first 1 digit, like 3.14. 2 decimal numbers after the decimal point. Right, 3 point. Let's try pi. Oh, because this is what I have to do double, right? Because Java integer divide integers get integer out and cast to double. There you go, 3.14, right? But if I want to do format, now this pretty much just do the exponents for me, right? So let's think about we have D, F, E, we have string. So string is just put white spaces in front. Same like 6 is going to be, like I said, it's including itself. Like true itself is how many letters? 4. So it's going to add just 2 more spaces in front to make it 6. False itself is 5 already. It's going to add just 1 more space to make 6. So the length is including itself. Okay. Like 10.2f percentage 5. 5 is pretty much just going to output the integer item with at least 5. If it's less than 5, then it adds spaces before the number. If it's greater than 5, then it's not going to add any more spaces. It's just auto increase the size for you. So 10.2 is just add, right, 10, including the number itself, and 2 is after the point. There are 7 digits located before the decimal points. If the number of digits before the decimal point in the item is less than 7, add spaces before the number. That's right. If the number of digits before the decimal point in the item is greater than 7, so it's not going to do anything. So 10 itself is including 2 decimal places and the decimal point itself. So that's why you have 7 left. The length of the whole set of number. Let's say we do 1. That's probably why it's never add, because the length itself. But if I do 10, it's going to add more spaces in front for me. Right there, to make it equals to 10. So what happened when I do D? So this is pretty much just a print format that it's not going to do, because there's an errors. Right, this is the whole number. Right? Whole number, decimal integers. All right. So let's look at another example. Like 1, 2, 3, 4 percentage 8d. So this make it length as 8, counting the number itself. Percentage 8s, same Java. Percentage 8.1f. So this is percentage. You can put minus, mean add spaces behind it. Right? If you don't put minus, it's add spaces in front. If you put the negative, it's adding behind and back. So it has to match the format specified. Otherwise, if you get the errors, I just show you, right? This is just show example. Alright, so that's pretty much it for chapter 4. Now you may finish your chapter 4 and 10 for this week. Okay. So let's review. Yeah, we pretty much just finished 4, 9, 10, unit 3 here. You could start working on 10 and 4. And we're gonna have the test on the 27th, right? Then we're gonna cover chapter 11, and then we're going to review for the test, and you can take the test right in a few weeks. And then we have to start to talk about the programming project for your final project. Then you can start working on that.
What is due this coming Sunday?
4 and 10, right? 4 or 10, and you still have 2 more weeks, but you should do at least one, right? Either 4 or 10. Then you don't have to push too many at the end. Okay? And then we're going to talk about final project. So let's start to think about final project. And I want you to start reading chapter 11. So chapter 11 is talking about polymorphism, right? So what is polymorphisms? Poly means many. Morphism means form. So you can have many forms. Object can have many forms. Can have many types. Okay. So we talked about inheritance a little bit already. So you can start to see how to create inheritance. How to use inheritance. And we can make polymorphism through the inheritance. Alright, so I think that's pretty much it for